Hello, students. Mr. Sulik here, coming up with today's virtual lesson. We're going to continue working on and understanding simple machines, but we're going to take it up to sort of the next level. And in order to do that, we're going to today's presentation or focus is going to be about mechanical systems. So in this presentation, you will identify simple mechanisms and how they're used to create mechanical mechanisms. So some of the things that are gone over in this video will be definitely a review, but there'll also be some things that certainly, when we're talking about mechanical advantage and whatnot, some things that we haven't had a chance to talk about in class. Okay. Introduction, mechanisms, change, a motion, a force, or both. Combining simple mechanisms into mechanical systems help us perform tasks that would not be possible by human power alone. And then finally, mechanical systems allow us to build bigger and stronger, lift heavier things, and move things faster. Definition of mechanisms. Mechanism changes input, movement, and force into output, movement, and force. So, example, riding on a bike, you're transferring the energy from your feet through the pedals. The pedals are connected to mechanisms within the bike that help prepare you to move forward. When mechanisms are connected together, they form mechanical systems that are known as complex machines, kind of like what we're creating in class right now. A machine that does a relatively simple task, but we're making it complex by adding numerous steps to that process. Some examples of mechanism in everyday use are simple scissors or a faucet, a wheelbarrow. Okay. Mechanisms can be used to change the speed, direction, and distance of an output. Three basic machines. Okay, we're going to go over these pretty quick. Levers and inclined planes and wheel and axle. Okay, all of these are using on your Rube Goldberg machine right now. Probably the one that gets used the most is inclined planes, but I'm seeing several machines that are using levers and wheels and axles as well. These machines were developed to help us perform physical tasks. They were beyond our human strength. The machines provide us with a mechanical advantage compared to performing the work without a machine. So, question number one, what type of machine is a seesaw? So on the Edpuzzle right now, I want you to go ahead and try to answer that question. Is it A, B, or C? If you answered C, that would be correct. Mechanical advantage. The diagram shows a lever being used to lift a rock. So we see the lever, see the heavy rock, and the log underneath. Pushing the lever down on the free end will result in the load being raised. The effort needed is less than the weight of the load. Okay, so the amount of effort that you're putting down to push this load is less than the weight of the load. The lever is being used to provide a mechanical advantage. So in order to get this heavy rock up, you're using this simple machine and applying effort by pushing it down. The length of the lever is different on either side of the log. So the distance from here to the log is considerably longer than the distance from here to the other end of the lever. This means only a small effort pushing down on the lever is required to raise this heavy load. The gain in effort is the mechanical advantage. Okay, so this is an example of a mechanical advantage. The mechanical advantage of a system is load over effort. So load over effort. And this can be written as MA standing for mechanical advantage, is equal to load over effort. So let's do a calculation. The mechanism shown is being used to lift a rock, and the rock weighs, let's say, 200 pounds. By adjusting the pivot point, this is your pivot point, of the lever, it was found that the rock could be lifted with 50 pounds of effort. So you would have to apply 50 pounds of pressure in order to lift this 200-pound rock. So you don't have to apply 200 pounds of effort to push up a 200-pound rock, but rather 50 pounds of effort. And why are you allowed to do that? Because you are using this lever. Otherwise, in order to lift this rock, you'd have to be able to lift 200 pounds. So mechanical advantage here is load over effort. So you're going to take the weight of the load, put it over 50 with a ratio of 4-to-1 or 4. So you would take 200, divide by 50, simple calculation of 4. So the mechanical advantage of a 200-pound object using 50 pounds of effort, the application of this lever is 4. So take a moment right now, answer this question. What is the mechanical advantage of the mechanism shown? So what do we know? We know that it's a load of 480 to 96. So what would be the ratio? We want to see how many times 96 goes into 480. So I'll take my calculator out. Okay, 480 divided by 96 equals 5. So it'd be a 5-to-1 ratio. There you go. All right, let's move on to the next one. So load over effort, 480, 96, mechanical advantage is 5. Velocity ratio. Mechanism can also be used to change the velocity of an object. So again, effort, we've got load here. When enough effort is applied to the lever, the rock moves. The distance moved by the effort of the lever is larger than that is moved by the load or the rock. So you have a large distance here. So when I'm pushing down on that lever in order to move this rock up, it's a much longer distance in comparison than from the ground going up. I have to be able to do that in order to lift the rock. So large distance here, short distance here, small distance here. The difference between this large distance and this small distance is something called velocity ratio. Okay? The velocity ratio of a system is distance moved by effort over distance moved by the load. So we know, let's say if we were to do this in inches, this would be 24 inches, and this might be 6 inches. Get rid of my mark here. The velocity ratio example calculation. This mechanism is being used to lift a rock. The distance moved by the effort to raise the rock is 6 inches. Okay, to raise the rock 6 inches is 30 inches. So I wanted to raise this up 6 inches, this 200-pound rock. It was going to take 30 inches of me pushing down with effort in order to do that. So the velocity ratio here would be 30, the big number, over the small number. It would be a ratio of 5-to-1, or the velocity ratio would be 5. All right. What is the velocity ratio of this mechanism? 27 over 4.5. Okay, so let's get our calculator out. 27 divided by 4.5 equals a velocity ratio of 6. This is where I'm going to stop the video today. Please make sure that you're answering these questions in your Edpuzzle. We'll do the second half of the presentation later this week. Thanks for watching and have a great day.